Welcome back. I'm Professor Bile, and we're going to talk for a few minutes now about residuals. So when we fit a line to data to try to describe a relationship between two variables, that line isn't going to go through all the spots, all the dots on our scatter plot, as we talked about before. So what that means is there's a difference between our actual value and what the predicted value would be. The predicted value being where on the line that would be. So for a particular x value, if we go up to the actual y value for that dot, that's the actual value. If we go to where the line is for that x value, that's the predicted value we're looking at. That's what our linear model is saying we expect the y value to be for x values like this. So the residual is the difference between the actual and the predicted values. Again, we're always going to have residuals whenever we have a what I'll call interesting relationship to look at. The only time you'll have no residuals is when a line perfectly fits through all of the dots on your scatter plot. That means you're looking at a relationship that is probably not very interesting. Real world data has more variation in it than that. So residuals are not a bad thing per se. They are something we expect to have with linear models, but looking at residuals can help us understand how well that model does at doing things like predicting what's going to happen. So I talked in the last video about the equal spread condition. We look to not have those residuals be fanning out to the left or to the right. The other thing we look for in residuals is if there is a strong pattern, something like a curve, then that means there's a relationship going on in the data that our linear model did not pick up. So a linear regression does a really bad job of picking up a inherently curved nonlinear relationship. So we can see that if we do fit a line to that data and we look at the residuals. It's called a residual plot. So on the x-axis, we're going to have either the x values or predicted y values. It doesn't actually matter which one we use. On the y value, on the y, we're going to look at the difference between the actual and predicted y values. If we look at this residual plot and we see a curve going on, it means there was a nonlinear relationship in our original data. Our linear model is not picking that up, and we have good reason to pause before we try to run with the results coming out of our linear regression. If we're trying to make predictions about, say, someone's behavior based on this linear model, and there's a nonlinear relationship, it's being shown in a residual plot, then we probably don't want to put much stock into the predictions coming out of that model. So next video, we'll talk a little bit about R-squared and how we use that as a measure of how well a regression is picking up a relationship between variables.